And the little subheading today is writing quotients as mixed numbers. Writing quotients as mixed numbers. And in order kind of to get the gist of this, write down this problem. Let's do this. I don't know, let's go with Chloe, Trevor, and Ellie will equally share 7 jumbo delicious, tasty chocolate chip deluxe cookies. How much, how many do they each get? Question mark, question mark, question mark. Now, we could spend our time, and we will, for this first one. We're actually going to draw this one out because it's not that many cookies and we could split them up. So here we are. As best I can, there's deluxe cookie 1, deluxe cookie 2, deluxe cookie 3, 4, 5, 6, 7. So there's my 7 deluxe cookies. They look mighty tasty at this point. So if we're sharing them, here's where we go. Well, we pass them out. Let's say Chloe gets this one, Charlie gets this one, Ellie gets this one. Now you go back to Chloe, she gets a second one. Trevor gets a second one. And Ellie gets a second one. But now we've only got 1 cookie to share amongst them. How in the world do we get them? What's the equal way for them to do this here? Jonah?
By splitting the last one into thirds.
Yeah, you're going to have to cut this last one into thirds. And they each get 1 of those thirds. So the answer to the question, Chloe, Trevor, and Ellie, is 2 1/3 cookies. Now, we don't want to have to do that every time because that can get a little bold, and whatever. What type of problem is this? If you're taking 7 and splitting it into 3 equal groups, we're adding, subtracting, multiplying, or dividing. Ellie Stewart, we are dividing. I am taking 7 cookies and trying to split them into 3 groups. Well, up until now, when you saw this problem, okay, you would just do the dividing. You do it 3 goes into 7 twice. That's where our whole 2 cookies came from. That's where this part comes from. But up until now, when we do our subtracting, we get this remainder, and we get a 1 left over. There's no such thing as a remainder 1 of a cookie. You know, if I gave Brady a cookie and said, you know, give Ellie remainder 1 of it, he would go, that makes no sense to me. So sometimes remainders, okay, we need to actually have something that's real. And how do you suppose we ended up with 1/3 as our fraction for that? By the way, here is a 1, that should be a clue. Where do you think the 3 1/3 came from? If I was just looking at this. Where in the world do you see a 3 over there, Olivia? No, the 1's right there. I said, where do we find the 3? Oops, I'm sorry, where do we find the 3? Do you see a 3 in this problem at all?
Yeah.
Where's it at? What's that, by the way, what's that called? The division problem, that little guy is called the? It is the did you say divisor? Right, and that's where the 3 comes from on the bottom of the fraction. The thing we used to call the remainder is now going to be the numerator of the fraction, And the divisor, the number of groups we're splitting it into is going to be the bottom of the fraction, or the denominator. So when you do a story problem, if it's something that can't be split into, I mean, if it's something that you can't break apart or you get a remainder of it and it's a story problem, they're gonna ask you to write your fraction, because you know what 1/3 of a cookie is, you don't really know what a remainder one of a cookie is. So when they ask you to write your division problems with your remainders as a fraction, that's what they're telling you to do. Take your remainder, put it over your divisor, and get that. Let's look at another problem. How about this one? Oh yeah, sure, how about this one? Bill cut the 5-pound, I didn't leave this one up, by the way, block of cheese into 4 equal parts. How big was each piece? Or each chunk? And again, you know that you're trying to cut 5 into 4 equal groups, so you know it's a division problem. 5 cut into 4 equal groups. Well, you know it's going to go 1 whole time, that's your whole number. But no longer can leave my remainder as 1, because a remainder 1 of a chunk of cheese does not mean anything. What is my fractional remainder going to be? What fraction do I get? 1 and, Kendall?
1/4.
Right, because you take the remainder, it goes on top of the fraction. You take the divisor, it goes on the bottom of the fraction. 1 and 1/4. Or what if you had, one more, just for fun. What if you had, I don't know. Let's say you had a 15-inch piece of string. And you needed to cut it in half. Although you can probably do that. No, let's cut it in fourths. Let's cut it into 4 equal pieces. Into 4 equal pieces. How long would each be? Well, cutting 15 into 4 equal groups. How many holes can we get out of there? 4 goes into 15 3 times, right? That's 12. My remainder, my leftover is 3, but there's no such thing as a remainder of 3 of a piece of string. What fraction am I gonna get, River?
3/4.
Right. You take the remainder, put it over there. There is such a thing as 3 3/4 inches of string, and you can cut it in there. Have you done this? Did you do this last year?
Yeah.
A resounding maybe, from what I
No.
understand.
Maybe.
There's an outside chance, you're saying?